In this video, I'm going to be discussing how to solve a system of linear equations by using substitution. Now, substitution is one of two commonly used methods for solving a system algebraically. Now, the nice thing about substitution is that when I have a system like this, it's actually a very straightforward process. So here's an example of a system. Now, a system is just a grouping of two or more equations. In this case, they both happen to be linear, and they both just so happen to be in slope-intercept form. This is probably the easiest case in order to use substitution. Here's how it works. What I have in the top equation is y equals 3x plus 2. In the bottom, I have y equals 1/2 x minus 8. What I'm going to do is a direct substitution. Here's what I know. In the top equation, y is 3x plus 2. Zoom in here a little bit. In the bottom, what I'm going to do is I'm going to substitute or replace y with 3x plus 2. So this is going to be substituted directly in here. So what I get is I get 3x plus 2 equals 1/2 x minus 8. So I have substituted, I've replaced y with what it is in the other equation. I'm ultimately trying to find where will these two lines intersect. That's a solution. Now, if you've watched my other video on how to solve an equation using a foldable, it looks like this, it's the same procedure. You're going to use the same steps of the foldable in order to solve after you substitute. So I like to draw a brick wall, keeps my work organized. So I look for a distributive property. There isn't one. I try and combine like terms on the same side. Nope, I'm good. So the next thing I'm going to do is move my variables. So I'm going to move 1/2 x. So subtract 1/2 x from both sides. So 3 minus 1/2 is 2.5 plus 2 equals negative 8. I next need to undo this addition, so subtract 2 from both sides. So 2 and 1/2 x equals negative 10. That cancels. And last but not least, I need to divide by 2.5. And that gives us x equals negative 4. So I've solved for x, let me go so you can see it, divided by 2.5. Now from here, I'm not completely done. If you watch my other video, once we get to this point of x equals, we're done. But that's not what we're doing. What we're trying to do is find the intersection of these two lines. Like I said earlier, these are in slope-intercept form. So, since I have an x, I need the y to go with it. This means that my solution is a point. And I'll do a video later about the different types of solutions. So from here, what I'm going to do is I'm going to choose one equation, one of these two equations, and plug in negative 4 for x. I'm going to choose the top equation. So what I get is I get y equals 3 times negative 4 plus 2. And then I just follow order of operations. So I get y equals negative 12 plus 2. Y equals negative 10. Now, it doesn't matter which equation you pick in order to solve the solution or to find your y. So down here, I've plugged in negative 4 into the other equation, worked it out, and I got the exact same answer. So my solution to this system of equations is a point. And my point is negative 4, negative 10. Here's another example of where I would want to use substitution to solve a system of linear equations. Now, this example is a little bit different from our previous one. In the previous example, we had y isolated in both equations. They were both in slope-intercept form. But in this case, I've got one equation in slope-intercept form and one equation in standard form. Now, this is another great time where I would want to substitute because I have y isolated. So like in the previous problem, what I'm going to do is I'm going to replace this y in the other equation with 3x plus 1. And basically do the same thing, but now there's a little bit more algebra involved. So here's what it looks like. I take x plus, I replace the whole thing with 3x plus 1, and you want to put parentheses around it. Whenever you do any form of substitution, whether it be plugging a number into an equation or substituting like I've done here, you want to put parentheses. And I'll explain why in the next example. So looking here, the first thing I'm going to look to do is see if I have to do the distributive property. Well, since there's a 1, that really doesn't change anything. So I can ultimately just drop the parentheses. So 3x plus 1 equals 9. Next, I'm going to combine like terms. So x plus 3x gives me 4x plus 1 equals 9. I'm going to undo addition, subtract. So I have 4x equals 8. And then finish by dividing by 4. So I get the x value of 2. So this means that our solution is going to be a point. Now, in order to be a point, I have to have an x and a y. So I'm going to choose one of these equations. I'm going to choose the top one, and I'm going to plug in 2 for the x to find the y that goes with it. So I get y equals, that's 6 plus 1. So y equals 7. Now to illustrate my point again, I'm going to plug in 2 into the other equation. This just means I'll have a little bit more algebra, nothing too intense, just subtract 2. So y equals 7. Since I got the same thing for both equations when I plug it in, my solution is the 0.27. This is a great way to check your answers. If you plug in the number into both equations, you have to get the same y value. If you don't get the same y value, you did it wrong, and you need to go back and look at your original problem. So here's the last example for solving a system using substitution. Like in the last problem, I have y by itself. So I'm going to be using substitution. Now in the other equation, y has a coefficient that isn't 1. So it's going to require one extra step, not a ton more, just one extra step. So like before, I'm going to replace y with 3x plus 1. So here's what it looks like. I have x plus 3. This 3 is the coefficient of y. We're only replacing y. We're not replacing 3. So 3 must stay. 3x plus 1 equals 9. Now since y had a coefficient of 3, my first step for solving this problem is going to be performing the distributive property. So let's go ahead and do that. So this is x plus 9x plus 3 equals 9. Then I need to go ahead and combine my like terms. So I get, that would be 10x plus 3 equals 9. Undo addition. So I have 10x equals 6. Divide by 10. So I have x equals 3/5. I just simplified 6 over 10. So my answer here is a decimal, and if you wanted to put it a decimal, there's nothing wrong with that. So it would give you, let's see, that would be 0.6. So I found my x value. I still need the y to go with it. So what I'm going to do, the same as before, is I'm going to plug in the value of x into one of my equations. I'll plug it into the top one again. So 3 times 0.6. I'll use the decimal in this case just to simplify it. You can do the fraction. It'll give you the same value. That's perfectly fine. So I multiply. So I get y equals, that would be 1.8 plus 1. So I have y equals, that would be 2.8. So I'm going to illustrate my point again. I'm going to plug it into the other equation and show that it works. So I have 0.6 plus 3y equals 9. This is going to take a little bit more work. So brick wall, subtract 0.6, 0.6. So I have 3y equals 8.4. Divide by 3. And again, it comes out to be 2.8. So my solution to this system is the point 0.6, 2.8. And that's a brief tutorial on how to solve a system using substitution.